Hello, and welcome to our session of data visualization in this class in Community and Population Health Dashboards. Today, we are going to have our first session and we are going to introduce some important concepts that are going to help us to understand this bigger idea of what data visualization is and how we work with that. The agenda for today is to review a little bit about the cascade of data, information, knowledge, and wisdom. Have a brief comments about why data visualization is important. Then start to describe that pipeline to build a data visualization, some specifications, some guidelines, and an exploration of some common terms. That said, then the first question that we need to ask ourselves is what is data visualization? And for that, we have different approaches. And when we think about what is data visualization, is basically any kind of visual representation that is going to help us to explore, examine, or communicate about data. And this is a definition provided to us by Stephen Few in a book that is called Now You See It, Simple Visualization Techniques for Quantitative Analysis. It's a book that you can find online. And it's a really easy to read and really interesting one. But the important thing is this: when we have visual elements that are going to help us to explore, examine, or communicate data, we are talking about a data visualization. But then, why is this important, and how this fits with informatics? If you remember, the big premise of informatics is this cascade of data, information, knowledge, and wisdom. And when we are transforming data into information, preserving that meaning, transforming that observation or that measure in something that the brain is capable of interpret and make conclusions, is where visualization is going to have a really important role in order to transform those raw elements from the observation of the world in something that our brains are going to use. But then, why is this so important? Basically, is because when we have data in visual form, it's going to increase our ability to think about it. It's going to activate different parts of our brain and the way that we think about the data, and even it's going to help us to remember that better, no? And if the visual representation then makes any pattern, trends, exceptions more easy to understand. But ultimately, is going to support our human factors and our capability to really abstract things from there. Then why is this important also? Because as you look into our world, everything is data driven. And it's one asset today. Data has a lot of value. That's why we have hackers. That's why we have criminal cybercrime. That's why we have all these problems, because there is value in data. And if we think about healthcare, where we are producing the double of data every 53 days, that's a lot of data, and there is a lot of interest in that, and there is a lot of value that we can extract from being able to utilize that data in a positive way. And if you think about it, all organizations have more data that they can even think about it. And that happens in healthcare. We're producing data by the second. And more organizations are actually taking that data and advanced analytics in order to make really strategic and operational decisions. And healthcare, public health, and the general domain is in health is not ignorant of this. And this is the only way that we are going to be able to move forward and make decisions quickly. And if we think about this, the visualization allows us to transform those abstract concepts that are hidden in the data into something that is physical, and we can actually view and interact with that. And it's going to support the capability to tell stories and convey some message. Then with that in mind, when we think about data visualization, there is a series of steps that we need to follow in order to obtain that. And that's what we call the pipeline of that data visualization. And the first thing that we need to think about is how we're going to import the data, how we're going to retrieve the data from where it's stored. No? And there are going to be challenges there and some processes, and sometimes we don't have the right format, we don't have the clean data, we don't have the proper chart set, and there could be a lot of things. But the first thing that we need to really be able to conduct is how we're going to retrieve that data, how we're going to import that data into our system. Then we need to prepare the data, because once you import the data, sometimes or most of the times we need to transform that. We need to normalize the values. We need to correct those data entries that are wrong, or we need to do something with the missing values in order to make a cohesive data set. Then once we have prepared the data, we can manipulate that. And then manipulation is not altering the meaning of the data. It means transform the data to ways that are going to be easy to use. Then we can filter the data. We can conduct other type of operations like joining, grouping, or creating hierarchies or dependencies by different variables, but always preserving the meaning. Then we can map, or we need to map. A map is basically see what are the type of data that we have and what is going to be the best representation for the or the attribute that is going to be representing the meaning that we want to convey. And lastly is the rendering, that basically is to transform that information, that data, into a geometric representation and that visual representation. And we are going to be covering that in a little bit more in detail, not only in this class, but in the whole process of the semester. Then when we want to specify a data visualization, we need to think in what is the data, what are the types of marks that we're going to be using, and how we map that data to those marks. And when we think about data, data is the records, the data that we need to visualize. And the transformation, as we presented in the pipeline, as those operations that we want to do, that we want to group, we want to filter, we want to sort, in order to facilitate the use of the data or to facilitate the communication of the meaning that we want. And this is one of those elements that when we talk data in informatics is the observation, but when we talk about data in visualization, we are talking about actually that collection of elements that we have already measured. And when we talk about mark or visual clues, we need to think about different properties or different things. Then a mark can have a type, and it could be a bar, a line, a point, or a color. It has a size, and the size can convey meaning. In when we have the width or the height of a visualization is going to bring a meaning, or the diameter of a circle. Legend is what is explaining the interpretation of some of the attributes that are not really direct convey meaning by the just visualization, and miscellaneous are other properties that we can have in those marks. But mapping is that process of putting the right representations to the correct data. In order to be really efficient and effective in data visualization, then we need to provide a proper specification of that visualization. And when we specify that, we need to be able to provide various ways in the way that the users can have what they want, or we need to anticipate the different uses of data. And that can lead to have, as we are going to be in the future, a little bit more of interactivity, or choose elements that can, in a simple image, convey a lot of meaning. And they say an image is worth 1,000 words. No, is a medium that we have there, and is reality also in data visualization, because image has the capability of having a better way of distilling the underlying meaning of data. Then when we talk about efficient approaches for data visualization, we are thinking in processes that allow us to create those visualizations in a more efficient and scalable way, especially when we are doing data manipulation in that pipeline and we're doing mapping, that is basically identifying the marks that are going to be conveying the meaning that we want from the data. And we also recommend that understanding what data to visualize, which story to tell, and how to visualize, it's a trial and error exercise. And this is going to something that needs to be validated by the users, and there is not a single way or a magical way of doing that. Even though we are going to see some recommendations, then it's important to notice that not one size fits all. Now, it's important to remember that understanding how to best visualize is a central challenge in improving healthcare, because we can use data for good, but we can use data for bad. And the way that we present the data can create misunderstandings or can direct the interpretation and the meaning in the direction that we are not really wanting to go. And here is a representation of those stages that we can follow to develop a specific design or develop a visualization. Then you start with a concept, then you start characterizing your data, we map that data, then we have different designs and we can iteratively going through that design. Then we have the actual visualization developed and we use that. At the end of the semester, I expect you to be able to build visualizations and be able to characterize the data, to map the data, to prove different ways of representation and actually deploy some of the visualization. And that's my aim, and that's going to be the deliverables that we're going to have are going to be practical in that direction. Then now let's move into common terms to understand data visualizations. And the first element that we want is the format or the type of visualization. And I already talked a little bit about this, and we can have two formats or two types of visualization. One is static, and the other one we call that interactive. Basically, when we have a static visualization, is that doesn't change, but it's really useful to support storytelling. Then they usually are in the form of diagrams, charts that are embedded in a larger body of text, like an infographic, but that text with the image, they are conveying some histories and they are telling some tales. And you can provide supporting evidence, related details in that text or in that context. And it's an emerging class of visualization that basically what it attempts is to combine the narrative with interactive graphics. And infographics are that type of example of a static visualization. And also we have the interactive visualization that is an enhancement in the way that we present that, because it is going to help people to explore, detect, and identify new patterns. And how it's going to allow that is because I can change the way that the data is presented to me, because the technology is helping me to transform in real data the way that are filtering or prioritizing or zooming or selecting the data to try to explore that. And then the theory says that this enables more effective population management, supports better understanding of health outcomes, and that's why we are going to be also exploring in depth this type of visualization where we can be interactive. And that's actually the element that is going to give us the introduction to the dashboards, because dashboard is a specialization of interactive visualization that is the ultimate goal of today. But it's important that every single visualization is going to have different elements that we want to see there. And one of them is the data source. It's really important that a visualization is telling us where the data is coming from, because that is going to create trust, is going to allow us to go back and compare if there has not been a mistake and error in the manipulation, in the transformation, in the retrieval, or if there has been update, apply the same techniques and see if there has been a change in the scenario that we are seeing the visualization. Usually you are going to find that reference in the bottom of the visualizations, and in this case we can see that data source in this case is World Health Organization and CDC. Sometimes we can have additional information about that. A data set is that collection of data in which the visualization is based. And sometimes the visualization allows us to access the data directly from the visualization and be able to see that table with rows and columns that are going to represent what is stored in a spreadsheet or in a database, and be able to map those things to the visualization that we are seeing. Usually we call rows the records and the columns variables. And this is going to be important because sometimes when we retrieve data, the data can be transposed, or things that we consider that records became variables just depending on the perspective that we want to have. Especially when we have multiple categories, then we can have records based on the observations, and in this case we have some countries. They could be records based on the countries, but we can have another variable that can group also the data, and that can become the observation, and the country becomes a variable. They could be interchangeable sometimes, but we are going to explore more in detail that. But it's really crucial and really important to define what is a record, because that's going to depend in what is going to be represented and mapped. And data sets, we have them just to try to see size patterns and some relationships that are not really easy to see in the graph sometimes, but you can see looking into the numbers or transforming that table. Then a variable, as we mentioned, is one of those columns that basically is a description of the thing that we are observing or the record. And we can have quantitative variables, categorical variables, qualitative variables, we can have text, and we are going to explore different ways of using those variables and how we are going to represent them. And every single one is going to have a restriction or a facility in conducting some of the operations that we can do on them. Then, and usually when you have a chart, it's going to present us the relationship between two variables, and they are going to be grouping the records in some way. And this is a specific thing. This is a bar chart, and the chart type is going to be that way of displaying in a geometrical way the data. And they can be of multiple types. And we are going to explore some of them today, and we are going to be going into detail in other classes. But every single chart type, they are going to use different marks, shapes, or layouts to represent the data. And usually those marks, shapes, or layouts are the ones that are going to give the name or the type of the chart. Then here is a bar chart that is common for us, and you maybe remember the pie charts or the line charts, but they're not the only ones that are there. And every single day we are developing or finding new ways to visualize data, really interesting ways of representing and displaying that. When we are thinking about charts, we need to think about axes. And many types of charts, they have axes. Usually we have the X and Y. The X is the horizontal one, the Y is the vertical one. And there are the ways to present reference for different values. We can have multi-dimensional charts, and we can have more than one axis, and they can be represented in the 2D representation, and then we can have a z-axis, or we can have other ways to represent multi-dimensionality that could be shapes, colors, and even in the interaction we can have ways of this moving through time or moving through space. And we don't necessarily always use axes, or we can have multiple axes as in radar charts that we're going to be in the future, where they are going to have different representations, and they allow us to create not only lines like here, but we can create shapes or areas and compute on those representations. And a scale is going to represent how we are measuring things. And we need to be mindful that not every single scale is from 0 to whatever value. We can have shorter scales, we can have logarithmic scales, exponential scales, then the distribution of the data is different. And those are some manipulations that can help us to improve the way that we are creating the meaning and producing the communication. Legend usually is the one that is going to help us to translate this meaning of representations that are not really easy to extract. And in this case of this map is the intensity of the color is talking about the number of cases or the density of the cases. And we are going to make the difference of density and number in the future. But basically, the darker, the more, the lighter, the less. That's trying to convey here. And that's why it's important, the legend, because we don't know, hey, how much is what, no? But the legend is going to help us to decode that message that is being conveyed by the intensity of the colors or the gradient or the different colors. Outliers is another important concept that we need to be familiar with, and it's basically when a data point is outside of what is expected, no? And visualizations is a really good way of identifying them, how something is out of the pattern and not following the sequence. And those are the ones that we are going to call outliers. In some interactive visualization, we're going to have input areas where we can put some information like searchers or filters or things like that to allow us to modify the visual representation. Then, when you are looking into a visualization, and this is going to be part of the discussion that we're going to have, we want to look into the title. What the author wants to tell us? What are the x-axis and scale that we are using? If there is any key, what is the data source, and what is the actual data? Not all visualizations are going to have every single feature, and it doesn't mean that it's a bad visualization, no? Because every single type of chart or visualization is going to require something different, but this is highly recommended. At least having a title, at least having a data source, and of course displaying the data is going to be really, really important. And is there some examples? Is a map not necessarily requires a scale, no, but it maybe is going to require a legend to interpret that. And sometimes the feature that we want to look into a visualization, especially when it's online or interactive, is not right away there. And there should be a button, there should be a link or something to be able to see them. But sometimes if we don't have these elements, it could be really difficult to interpret. Then the idea is to at least expect for these things, and when you are providing them, think about that. And this is basically what I told you, that when you are looking into visualization, ask you, hey, are these elements present there? Now, let's talk about charts and the type of charts that are available and that we can think of and implement just as an introduction to the to the concept. Then the chart that we select is going to depend in the format of the data and the size of the task that we want to do. Then if you have a lot of workload, then how big a task of reading this visualization feel like it will be? Then maybe if it's too difficult to interpret it, we need to use a different visualization, or we need to have multiple visualizations to convey different meanings, and then we use the title to try to orient the user in the way that we are using that. And if we have a static visualization, how large and varies the content? Is it dense display with lots of charts and text, or is it quite small and compact? And that's how the task is going to be. If it's this interactive, how much interactivity is there? Are there many buttons, menus, options? How much do I need to interact with that? If the visualization doesn't fit in your screen, how much scrolling and how much different pages will you have to look through the whole thing? And this is going to be important because people is going to get tired. And then the format and task size is going to determine that the most important things, usually we want to have them in the top at the beginning, because we don't want to have the really important message to be hidden when the people is just tired of looking for that. And also we need to think, what is the task that we are trying to achieve? If we are comparing data, if we are looking for how the data is distributed, if we want to look how the different categories or the different composition of data is, or how one variable relates with another one. And then this chart kind of help us to identify what kind of chart we use, no? And it's not a complete one, but these are the type of questions that we need to ask. Hey, what we want to show, no? And then once we have that clear, we go and select the type of chart that we want to use. And you can see that some charts can serve for multiple purposes, no? Like the scatter plot could help us to show relationships, but also can help us to show distribution in some cases. Or the line charts can help us to show composition or show us comparisons, no? And we just have a slightly different way of presenting the data, but they are going to be helpful in those elements. Then when we are thinking about visual functions, based on those tasks, then we can have distribution, correlation, ranking, part of a whole, evolution, map, and flow. This creates kind of a hierarchy that you can go to that web page, and these are a gallery for art graphs where you can look into the alternatives that we have. Then you want to look into distribution, we have here different other functions, no, or other chart types, the violin chart, the box plot, the rip line, or for correlation, the heat maps, the choroplates, the bubbles. For ranking, we have the spider radar, the word clouds, the lollipops. There are tons of them. Part of a whole, then we have the dendrograms, we have the pie charts. For evolution, we have different type of stack bars or time series, and maps are going to be able to convey a lot of information. Or for flow, we can have the the core diagrams that are used to analyze networks. On the actual network, the Sankey diagram that allows to analyze flows. And these are really, really cool things that we're going to be exploring. Then the bar chart is usually used to represent quantitative values. And in the X, we have categories, and in the Y, we have values, or we have percentage. Yes, but usually it's the way that we represent things. It's a common error that we have categorical variables here, and people put points and connect those dots or those points with lines. That's a common error, and it's not the best way, because if the categories are not necessarily connected and they are not in sequence, there is no reason why you want to connect those dots. The stack bar is when we have comparisons or lengths of two or more components, and we can represent them as a portions of a total component, or we can just do absolute comparisons on those categorical values. When we have the radar chart, this is one of those multidimensional elements where every single axis is going to represent a dimension, and you can have as many as axes as you want. The most important thing is based on that area, that shape that is drawn there, you can see, hey, what it looks like other groups, or what is different. And the pie chart uses the circular portion, and every single segment is going to represent a part of the observation. We also have the scattered plots, where we have two variables, and then we have that numerical, and we have the point where they intersect, and it allows to identify clusters, to identify distributions, to identify tendencies, and there are a lot of manipulation that we can do in the scatter plot chart. The other types could be heat maps. The one that we already mentioned, that is the line chart, and the line chart has the points, the values connected, and they are really useful when we have dates, because yes, that's going to tell us the story, the tendency, and things are going up, going down, and allow us that kind of observation. And the slope graph is just a specialization of a line graph that allows us to analyze things in what is the level of change. We can stack areas, we can stack lines, and that's going to provide us with other type of information. Then we have the stack area chart, and we have the choropleth map, that is a map that uses different densities to represent quantities. And we can have symbolic or symbol maps, where we can use a symbol, and the size of the symbol is the marker that is going to tell us the quantitative value. Or we can even combine colors and size, and then we can have not only the geographical location, that is basically 2D, plus two variables that are represented in those dimensions. This is the Sankey diagram, where we have a evolution over time, or a grouping, and how they evolve. And they're also called flow diagram or alluvial diagrams. Then it's really important to identify that there are challenges in data visualization, and creating custom visualizations has multiple sources of problem. And to create a really good visualization is a combination of skills, tools, data analysis, design, and development. Those are the skills that I want you to develop. And when you as designer or developer need to gain understanding of how the data set works, what are the characteristics of that data, and design the mapping, the aesthetics, and the iteration based on that data and the message that you want to convey. Then 10 key rules when you want to present visualize information. You need to know your target audience in the way that you are going to use the naming, labelings, even the colors or the font sizes. Make sure that your data is clean, because when the data is not clean, then you are going to have outliers, you are going to have gaps, you are going to be in trouble trying to represent things. Select the right chart, and we are going to do more exercises on matching the charts with the data types and really narrow it down to be effective in that. Label those charts effectively. I already mentioned the title is really important, because that title is the prompt in how we are going to use the visualization. And we can emphasize important points. We can use colors, marks, representations to emphasize what we want the people to pay attention to. When we convey this in a dashboard that we are going to introduce later, then use the best platform that you can use, and the best usually is the one that you know how to use. We are going to explore different tools to create them. Be mindful on formatting your charts for accessibility. That means font size, contrast, colors. And when you are using color, there are really interesting tools that we're going to test and see how colorblind people can really use a color visualization or not, but color can have meaning as well. Ensure that your data is readable in any format that you want to distribute, and always accept feedback. Okay, if somebody says I cannot use this, it's a better way of improving, yes, just change. Then let's focus in the specification of visualization. That is a dashboard. And basically a dashboard is a visual and interactive performance tool that displays in a single screen the most important information about different things. But the key element here is that you can interact with them. Then dashboards are going to incorporate visual and functional features. They are going to allow users to understand current practices or clinical variations, benchmark clinical data against clinical indicators, and they can provide visual summary decision related in graphs, charts, or interactive tables. These are kind of examples of dashboards, no? A dashboard can have functional features and have visual features. And a dashboard basically the functional is what it can do regarding of transformation manipulation, regardless of how is that displayed. And the visual features refer to those visualization principles that we have already introduced briefly. Then we can have different type of dashboards. We can have strategic dashboards, analytical dashboards, or operational dashboards. The strategic dashboard are those high-level overview of a problem, and they are going to have really important metrics for the performance that we want to identify. And usually they can have just one measurement represented there. The analytic dashboards are basically snapshots of a collective data that we have observed over time. An operational dashboard is the one that we use in a daily basis. For example, the occupation of beds, the outbreaks, or things like that are going to be operational dashboard. Then it's really important that every single dashboard is going to have interactive visualization. And this is about the drill down capabilities as a key functional features. And we need to balance between how much detail we want to do there, how much filtering we want to have there, and how much zooming. But allowing that is really a capability of a dashboard and going to make it different when you are really interacting with that. Common mistakes is not providing the right context, using poorly designed display media, encoding the data in the incorrect way, showing too much detail because too much busy is going to be difficult to read, uh, not highlighting the important data, putting variability there, colors or things like that that has no meaning, and the data is not sorted or not or is chose disorganized and is not ordered in a way that we can really follow the story that we want to say. But really important, want to organize information to support its meaning. We want to be consistent. We want design for use, and we want to test our designs for usability. Then the best practices and guidelines for dashboarding is we want to tell a clear story. The most important starts from the top and from the left. I already mentioned that because if you have something that goes more than one screen, the people is going to be tired and not willing to really scroll down and try to see things. The users need to be able to retrieve most important information in 5 seconds. The most important thing should be highlighted and involved. Then we don't want users to be switching with more than 10 interactions. Colors only to provide visual cues, but if we want to convey meaning by color, then you need to be mindful for inclusivity that the color is not going to be problematic for colorblind individuals. We don't want styles that are going to compete with information, fancy fonts or things like that. Here the KISS principle apply, keep it simple and short. If possible, a dashboard should support the drill down feature that we already mentioned to be able to go from the general to the more detail in there. Then here are some examples of dashboards that basically we have different visualizations grouping different functionalities and displaying different charts that are conveying different informations. And then we can have performance dashboards, how people are achieving goals, and that could be the example of this on the right. We can have also quality dashboards that are comparing with another performance. Safety dashboards. Hey, are we having accidents? We are having unexpected events. Clinical dashboards, flow in the hospital. Patient perception dashboards that are telling us what are the evaluations. The health organization dashboards, what is the revenue, what is the flow of patients, and how things are doing. Then in summary, we remember a little bit about the data information and knowledge cascade. We define the data visualization. We explain a little bit why this is important and how nowadays data is an asset. We introduce the pipeline and the different processes to build a visualization. We talk a little bit about how we specify a data visualization, especially mapping data to their marks. We provide some guidelines, especially understanding common terms, provide an example of some charting, and we introduce the concept of dashboard. Then I'm looking forward for the discussion and thank you very much.